Okay, so we're going to start out with this equation. H2 plus Cl2 is definitely in equilibrium with HCl already. I mean, 2 HCl. Now it's balanced. These both have a coefficient of 1, coefficient of 2. So because it's already in equilibrium, we can say that K of C equals the concentration of HCl squared over the concentration of H2 times the concentration of Cl2. Okay, take that in for a second. Now if we went to find K of P, then we would just have the pressure of HCl squared over the pressure of H2 times the pressure of Cl2. Take that all in. If you didn't want to have to find Kc and Kp, what you could do is use the equation Kp equals Kc times RT to the change in N. Now what that basically means is if you were going to do Pivnert, if you divide the V and the N over V equals molality. And that's what K of C is in. And K of P is in pressure. So if you want to do pressure, to get it alone, you divide it by V. So you have molality RT. And so that's basically what's right here. Molality RT. R is like the constant they use for Pivnert. Like if you're doing atmospheres, it's 0.821. And delta N is normally always 1 because it's like 1's go to 2. So you're normally fine with that. Or you can easily just convert it by yourself. Okay, so that's K of C. Now what I meant by the ice chart. Let's get a new equation up here. Let's say we had SO2 Cl2. That's in equilibrium with SO2 plus Cl2. And it is in a... No, I'm not even going to care about that. Okay, so that's your equilibrium equation. It's not in equilibrium yet. Let's say you started out with 0.1, well I'm going to write I, C, and E. You start out with 0.1 atmosphere molal. So it would either be atmosphere / molal. What you do to find molality is moles over a liter. Now for both of these things you started out with 0. Because you're starting out with that and you're going to try to find out what would be the equilibrium. So that is going to convert into those other products. Reactants convert to products. Okay, so to do this, you have to minus an X for SO2Cl2. And this is what throws people off sometimes. 1 mole converts to 2 moles because there's 2 products. And so that means that you get plus an X here and plus an X here. So overall it's like you subtracted one atmosphere, let's just say, of that, and you gain 2 atmospheres. Well, that's okay, it just makes sense. So then you would do 0.1 minus X, X, and X is your ending thing. So to find it, you know that you can do K of C or P, doesn't matter, equals SO2 Cl2 all over SOCl2, SO2Cl2. And when you do that, say, in most of the problems they'll give you a K and you can just plug them in. So it'd be like X times X over 0.1 minus x. And then you can just solve for it. And so you see how this would end up being x squared on the top? Well, sometimes it equals like 1 minus x, well 0.1 minus x quantity squared. And if you ever have that, then you can just take the square root of everything and then the square root of k, because it's a lot easier to work with that. And it will normally become a quadratic, so use quad form, use factoring, they'll make it easy. You never know. Okay. Then Le Chatelier's principle just means that if you have an equation, no matter what you do to it, it's going to want to relieve the stress. So if you put like a ton of pressure on the system, this has 1 mole of this and this has 2 moles. So for every 1 mole of this you get 2 moles of these things. So if you put a lot of pressure on the system, it's gonna want to shift this way because you want to go from 2 moles to 1 mole to relieve the stress. And pressure, what you need to know is a key point, is that you have to work with the volume. If you add pressure by adding another gas, it will not do anything. Also, adding a catalyst won't do anything, and raising the temperature depends on the situation. Okay. Okay. Also, if you don't know mechanisms, you should probably learn it. So, what you basically do is, mechanisms are a way that a chemical reaction actually happens. If you want to do a reaction, the final thing of this one would be, okay, well, let's figure it out. So let's say you have these steps. 2 NOs yielded that. Well, you made that, and then in step 2 you used it, so cross them out. Then using that and adding H2, you made H2 and NO2. And the next one you used N2O, cross them out. Then see, you can't cross anything out, so you drop them all down. In this one you have 2 NOs plus 2 H2s yields on this side N2 plus 2 H2Os. So that's your equation at the end. And that's how it happened. Well, each one would be labeled as fast, slow, or fast or slow. And if the slow one was first, then the ratio of the coefficients will help you find the rate. But it's always the slow one. So in this case, it's our second equation that we're going to be looking at. So I'm going to erase 1 and 3 because I need more room. And what you would basically do is, from this, you can write R equals some constant K times you still use the coefficients, but N2O2 and H2. So that's your rate. But when you look at that, that's not N2O2 isn't something that you start with. So it doesn't make sense. So you have to change it out. And in the first equation, you created N2O2 by adding 2 NO's. So the reaction forward equals the reaction in reverse. And so if you did KNO, KNO, that equals the same thing as KN2O2. And so you can substitute it in. So it would be R equals some constant K NO squared times H2. And that's an easier way to find a rate law. But I don't know if you see, because then you have everything that you started with. But I don't know if you need to know that. So I'm done.